Hello everyone, welcome to today's webinar. Today we'll go over the first section of Unit 6. Unit 6 is the last unit in Algebra 1. So we're going to cover that unit hopefully over the course of 3 webinars, and this is the first webinar among the series that we're going to dedicate for that unit. Today we're going to look at algebraic fractions. We're going to learn what algebraic fractions look like and how we can divide and multiply algebraic fractions. First, I want to introduce myself. My name is Miriam. I'm your math instructor here at Penn. I am certified to teach high school math in the state of Pennsylvania, and also I have my master's degree in education. Today, we're going to go over the most challenging topics in the first section of Unit 6. There will be self-check questions for you to try within the webinar today. Those questions are not graded. Those questions are provided for you to assess yourself and see where you stand in each topic. Your questions are welcome. Please keep them relevant to what we speak about during the webinar, and you can ask your questions actually by typing your questions in the questions box. The raise your hand feature does not work in our webinars. All registrants for this webinar will receive recordings whether you attend or you could not attend today. Today we're going to go over how to find the greatest common factor for an algebraic fraction. Also, we're going to learn how to reduce an algebraic fraction and how to multiply and divide algebraic fractions. So let's start with a review from, I would imagine it was last webinar that we went over how to find the greatest common factors for terms, for two monomials. And we went over the tree method. If you remember the tree method, we were thinking about finding the greatest common number between 64 and 32. And also for variables, we said that the variable with the least exponent would be part of our greatest common factor. So let's review that concept because we're going to use that in finding a greatest common factor for an algebraic fraction. So if you do the tree method, you will find out that 32 actually is the greatest common factor between 64 and 32. And therefore, 32 will be part of our greatest common factor. Now, as for variables, we're going to look at x and x. X and x are common because I see x squared and x cubed, so they appear in both terms. So I'm going to take the one with the lowest exponent. So x squared is going to be part of the greatest common factor. Y and y, but y to the first is the least, so that will be part of the answer. Z and z to the second, then z would be part of the answer. This is the greatest common factor of this term, this monomial, and that monomial. How can we use that for algebraic fractions? An algebraic fraction, just to begin with, is just a fraction. But instead of having numbers on top and bottom, we're going to have a monomial on top and a monomial on the bottom. Later on, we're going to see a trinomial maybe on the top and then maybe a binomial on the bottom. So it's like a fraction. How can we reduce? How can we put this algebraic fraction in simplest form? Well, there's two ways to do that. And we went over this, if I'm not mistaken, in Unit 1, if I'm not mistaken, we have gone through how to divide two monomials. So that is a method to reduce an algebraic fraction. Another method is to find the greatest common factor between the top and the bottom monomial and divide over this greatest common factor and reduce. So since we went over how to divide monomials previously, let me show you how to reduce an algebraic fraction using the greatest common factor. So the first thing I want to think of, what's the greatest common factor between 35 and 49? From our knowledge of the multiplication table, we know it's 7. 7 would be the greatest common factor between these two numbers. As for variables, we said we're going to take the common variables with the least exponents. So that would be a, that would be a b, because b squared is greater, so we're going to have the least b. C cubed and c to the fourth, so I'm going to go ahead with a c to the third. So this would be the greatest common factor. To reduce the fraction, divide top and bottom over the greatest common factor. So divide over 7a, b, c cubed and divide over the same monomial or greatest common factor equals. Now, again, we're going to go back to the rules of dividing monomials. We're dividing one monomial over the other. So we know how to do that with numbers. 35 over 7 will give you a 5. And then a squared over a, we subtract exponents. So 2 minus 1 is a. And then b over b, that's going to just cancel out. And then c cubed over c cubed, if you subtract the exponents, will give you c to the 0 exponent, and that would equivalent to 1, so they will cancel out. So that would be on the top. On the bottom, divide 49ab squared c to the 4th over the greatest common factor. 49 over 7 is a 7. A divided by a, that cancels out. B squared over b, subtract 2 minus 1 will give you a 1, so it's going to be a b. And then c to the 4th over c to the 3rd will be c to the 1st. So this is the reduced form of this given algebraic fractions. If you want to only divide not using the greatest common factor method, just divide 35 over 49 and try to do a squared over a will give you a in the top, and so on, like the old method. You should have the same answer. This is only a different method. Let's repeat the same thing for number 2. I have a negative value on the top. I'm not gonna panic because I have a negative. I'm just gonna leave it till the end. I'm gonna look at the number parts and the variables parts. So the greatest common factor would be a 25. That's between the 25 and 150. And then I have s, t squared and t to the 3rd. I'm going to get the t squared, and u is not common at all because I have a u on the top and nothing for the u on the bottom. So u is not part of the greatest common factor. Divide 25 over 25 st squared and divide over 25 st squared. And write the fraction in reduced form. So we're going to have top and bottom. Sometimes the denominator is a 1. So in this case, we're just going to have an answer with no fraction form. We're going to see later an example like that. So negative 25 over 25 is a negative 1. So negative 1. We just don't write 1 in algebra. So we're just going to have the sign there. S over S cancels out. T to the 2nd over T to the 2nd canceled out. U over nothing is U. On the bottom, 150 divided by 25 will give you 3. And then you will divide S to the 5th over S to the 4th. Actually, this is 6. I was suspecting my answers here. 6 is the quotient of 550 over 25. That makes sense now. So it's 6. And then S to the 4th. 5 minus 1 is a 4. And then T to the 3rd, T to the 2nd, subtract, so it's going to be a T. So your answer, I'm going to rewrite that in a clear way, negative U over 6S to the 4th T. This is the reduced form. So what is a reduced form then? This fraction, this algebraic fraction, is equivalent to the original one, but the extras has been eliminated. So this is the reduced form of this fraction. If you have any questions and you just joined our webinar, you need to type your questions in the questions box. The raise your hand feature is disabled in the webinars. Any questions so far in how would we find the greatest common factor and how to use that in reducing an algebraic fraction? Okay, let's see more examples where we have different kind of greatest common factors. 13 and 16. nothing common between 13 and 16. So they have to stay in our answer as is. So your greatest common factor should not always have a number. If there is nothing common between the top and the bottom number, then those numbers will stay in your answer. So far we have 13 and 16. Okay, we have p on the top, no p's on the top. So p is not part of the common factor, so p squared will stay in our algebraic fraction, but not in our greatest common factor. Q and q squared, so the greatest common factor then is q. R is not in both top and bottom, so only R will appear where it belongs to the top. Now q, if I'm going to divide over q and divide over q, q over q is a 1, q to the second over q is just 1q, so that would be your answer. Okay, I have a question. Aren't you supposed to change a negative into a positive when dividing fractions? If you're dividing negative over a negative, yes, your answer will be a positive value. Example, negative 12 over negative 6, that will give you a positive answer, positive 2. But if you're dividing negative 12 over positive 6, your answer will be a negative 2. Thank you for the question. Last question on this topic, negative 6, and this is the one that's going to answer your question. Negative 6 m to the 5th n over negative 30 m squared. So as for numbers, I'm looking for the greatest common factor between 6 and 30. So the greatest common factor is going to be 6. Because with the multiplication table, we know that 6 times 5 is 30. So 6 should be part of the greatest common factor. The greatest common factor will have a 6. And also I see m and m, but I'm going to choose the one with the least exponent. N does not appear on both, so n is not common at all. So I'm going to divide over 6m squared and then over 6m squared equals 2. Now, negative 6 over positive 6 should give you a negative answer. So it's a negative 1. Okay, and then we have m to the 5th over m to the 2nd, then subtract 5 minus 2 is 3, then it's going to be m to the 3rd. And then n is not common, so n will just stay on the top. Negative 30 over positive 6 will give you a negative 5. And then m to the 2nd over itself, it just m to the 2nd. I'm sorry, over itself just 1. So negative 5 is the only value in the denominator. Now, negative over negative, negative 1 over negative 5 is a positive value. So I can just cancel out those signs and rewrite my answer as m to the 3rd n over 5. Any question? Okay, so let's move on to a self-check. So the self-checks again are not graded. So these are part of our webinars here just to give you a way to self-assess yourself and see where you stand from finding a greatest common factor for an algebraic fraction that's given like the one in the question. What's going to happen with those questions is that I'm going to keep my screen for about like 30 to 40 seconds. You can look at the question, look at the answers, make up your mind on the answer, and then I'm going to change my screen to give you the same question and then the ability to input your answers. So that way we can all participate and share our answers. So here you go with the question. Try to apply the rules and see which answer is the greatest common factor of this given fraction. Okay, I'm gonna change my screen to give you the same question, and please participate in those questions. Here you go. Okay, I'm going to share my final answer for this question. If you want more time to work on this question, you can pause the video whenever you get the recording and take your time doing the question. Remember, when you see a question like that and you know the rules in your head, but the exponents and the variables and the numbers just confuses you or overwhelms you, remind yourself that no matter how the question looks hard or difficult, as long as you know the steps to do the question and to think about it, do not overwhelm yourself. Do not panic. It's all about using the rules and applying them in order and applying them correctly. So the question is not asking you to reduce the fraction, it's asking you to find the greatest common factor between the top and the bottom in this fraction. So it is 5s t to the fifth. The R and the U does not appear in our answer because they are not common on top and bottom. So the answer in this case would be C. Okay, well, let's see then if we are asked to reduce a fraction like that and find the illegal values of those fractions. Whenever we have fractions, and especially if those fractions have variables in the denominators, we need to be cautious of the values of the denominator, the values of the variables that make the denominator zero, because we know that any number over zero is not defined in real numbers. So if you are thinking about 5 over 0, you're always going to have like an error from the calculator if you try to do that. So that is undefined answer. So that's why the illegal values, the values of the variables x, y, and z, that are not allowed to be used in the denominator. So this fraction have a value always. So reduce the fraction. I'm going to remind you of how we did the old way. How did we divide the top and the bottom without using the greatest common factor, just to reduce that fraction? So negative 27 over 9 is a negative 3. And then x squared over x to the third, we're going to have x on the bottom. Remember, 2 minus 3 is a negative 1. So x to the negative 1 means the x to the first exponents have to go in the denominator. The negative exponent just makes the variables switch to the denominator with a positive exponent. Y to the sixth and y to the second, 6 minus 2 is 4. So y to the fourth is going to be on the top. And then z to the fourth, and then z over z, that would be z to the third. So this is how you reduce the fraction another way, just by dividing. Now the illegal values, we need to look at the original denominator, this denominator, not this denominator. We need to take that denominator and equal it to 0 and see which values of the variables x, y, and z that makes the denominator 0. So we would just call them illegal, don't use them, equals to 0. Now remember, from the last webinar, we spoke about the zero properties when we were solving equations. We said that the zero property, whenever you have quantities multiplied together and then equals to 0, it means that any of those variables might be 0, because 0 times anything is a 0. So that makes us say, well, x might be 0, or the y might be the 0, or z might be the 0. Those values are not allowed in this fraction. So these are the illegal values. And one more time, the more common mistake I see is that students will go and bring the illegal values from the denominator of the reduced form of the fraction, which is not correct. We need to go to the original denominator. Any questions? Okay, let's move on to algebraic fractions with a trinomial on the top. And by the way, if you see those sections in my slides, I have like a frame around them. These are notes. These are the summary of the rules that we follow in each kind of different questions. So if you want to write them on your notebook, if you want to just read them and keep them handy, so whenever you're working on a question, you can just, remind yourself of how we do that question. Now, this fraction has a trinomial on the bottom and a binomial on the, trinomial on the top and binomial on the bottom. What should we do to reduce that fraction? Remember that we learned how to factor trinomials. How we factor trinomials is that we had two sets of parentheses. So if I want to factor out or factor this trinomial, I'm going to have two sets of parentheses, and I have to place a here and a there. If you want to review how to do that, you need to watch the webinar on how to factor trinomials. And then the signs will just tell us the signs of the factors. So what we're looking for are factors of 28. When you multiply them, you get negative 28. When you add them, you should get negative 12. If you do your P's and Q's from the last webinars, we said P and Q, we list the factors of 28. So it's 1 or 28, 1 times 28, or 2 times 14. Another option is 4 and 7. Now, since we multiply them together and get a negative answer, negative 28, one of those values has to be negative. But which one? Are the Q's negative or the P's negative? Well, since we add them and we had a negative answer, it means that the bigger values here are the negatives. Now we need to try and see which one will give us negative 12 as a sum. And you will know it is going to be the 14 and the 2, because negative 14 times 2 will give you negative 28. And also negative 14 plus 2 will give you negative 12. So the factors I'm looking for are negative 14 and positive 2. Now I factor the trinomial. Over, the question says over a plus 2. Now I see a plus 2, that's a factor, over itself. Just cancel out. Equals to a minus 14. So a minus 14 is not a fraction, but this is the reduced form of the fraction given. Now, what is the illegal value or values of this fraction? You might say, well, this doesn't have a denominator. Remember, go to the original fraction, equal the denominator to 0, solve. So when you solve, you're going to subtract 2 and subtract 2, then a equals to negative 2. Negative 2 would make this fraction undefined because look, negative 2 plus 2 is a 0. This trinomial over a 0 is undefined. And that's why we call this an illegal value. Questions? Okay, let's proceed to more examples. A trinomial over a trinomial. Well, remember that we spoke about trinomials that does not factor. Some trinomials, you cannot just factor them. But whenever I see a trinomial on the top or the bottom or both, I'm going to attempt to factor them, just in case that they are factorable and I'm able to cancel out factors and reduce the trinomial. So I'm going to try my best to come up with a factor. So I'm going to have two sets of parentheses here. And here, because we have trinomials top and bottom, we have x and x. The signs tell us that one would be a positive and one would be a negative. The bottom one, both would be positives. Now, my job is to find For the top, I need to find factors of 18. When you multiply them, it will give you negative 18, but when you add them, you get positive 7. And the answer would be 9 and negative 2. Negative 2 times 9 is negative 18, and then add, it will give you positive 7. This is how you can check. The bottom one, factors, when you multiply them, it's 45, but when you add them, it's 14. So everything is positive. So it's going to be a 9 and a 5. Check. 9 times 5 is 45, and then add, it's going to give you 14. Now I factored top and bottom. My job is to find same factors appears on the top and the bottom and cancel them out. So I see x plus 9 and x plus 9. So reduced form is x minus 2 divided by x plus 5. Illegal values, look at the original denominator. Now, remember when we solved trinomials, trinomial equations? We had to factor them first, then equal to 0. We had to factor them first and then use the 0 property, where I did already factor the trinomial. I'm just going to use those factors, the same factors for the denominator, and then say, well, according to the 0 property, either x plus 9 should equal to 0, or another possibility is x plus 5 is the 0. And then from there I say, well, then x either negative 9 or x is negative 5. These are the illegal values. If you plug in negative 9 or negative 5 in the denominator, it will make it undefined. More questions on reducing fractions with trinomials, or here we have a binomial. Now this binomial, of course, it's not a trinomial. I'm going to factor it like the other ones, but there has to be some way I can factor this trinomial, since I see 3 and 27. So 3 and 27, there is a common factor between 3 and 27. So let's do 3. I should be here an m actually. There an m there, 27m, I believe. So factor out 3m, because 3 is a common factor between 3 and 27. M and m squared, we're going to take out the m. So divide 3m squared over 3m will give you an m, 1m, and then minus 9, because 27m divided by 3m is 9. And then divide over trinomial. Try to factor the trinomial. Okay, factors of 36. When you multiply them, you get negative 36. When you add them, you have negative 5. If you think about it, it's going to be m plus and m minus. The bigger one would be a minus, so when you add, you have a negative value. So 9 would be the minus or the negative, and then the 4 would be the positive. 4 times negative 9 is negative 36. Add, it will give you negative 5. Now try to see anything common. M minus 9 and m minus 9 will just cancel out. Your answer is 3m over m plus 4. That's the reduced form. What are the illegal values? Look at the denominator. So I'm going to equal m squared minus 5m minus 36 equals to 0. It's a trinomial. Then use the factors I have on the bottom, times m minus 9 equals to 0. According to the 0 property, either m plus 4 equals to 0. In this case, m equals to negative 4, or m minus 9 equals to 0, and then m equals to 9. Those are the illegal values for this algebraic fraction. So the main idea is whatever you have on the top or the bottom, try to factor that, either by finding the greatest common factor like this binomial, or by factoring a trinomial. and then see what you're able to cancel out to arrive at the reduced form of the fraction. One last one I would like to go over with you is when we have a trinomial on the top, we know how to factor that, but we have a binomial. But this binomial is not like any other binomial. This is a difference between two perfect squares. K to the second, k squared, is a perfect square, and 9 is a perfect square, and you have them subtracted. So if you remember, we had a special way to factor the difference of two perfect squares. So the special way I'm referring to is that we had two sets of parentheses. We're going to have k, and we're going to have a k once with a plus, once with a minus, and both will have the 3. And 3 comes from the square root of 9. So that would be the factors for this binomial. So whenever you have a binomial, just keep an eye. Maybe it's a difference of two perfect squares. The trinomial, I'm going to try to factor. I'm going to have a k and a k. I know it's going to be a minus and a plus. Well, factors of 15, multiply them, you get negative 15. But when you add, you have negative 2. So I'm going to have 5 as the negative and 3 as the positive. Check. Negative 5 times 3 is negative 15. But when you add, it will give you negative 2. So that is a sign that we are correct on our factors. Cancel and cancel k plus 3. And nothing else is common. Then your answer is k minus 5 over k minus 3. Illegal values, original denominator. K squared minus 9 equals to 0. Factor, we did already the factors for these, so it's k minus 3 times k plus 3. Either k minus 3 equals to 0, and that makes k equals to 3, or k plus 3 equals to 0, and that makes k equals to negative 3. Then these are the illegal values. Any question? Anything that was not clear on how we plan to reduce a algebraic fraction, or how we factor, or why do we cancel out things there? Okay, let's go to a self-check. So reduce this algebraic fraction. You have a binomial, and this is a special binomial C, and then you have a trinomial. What is the form that you can say that this is the reduced form? This is the simplest form of that fraction. I'm going to leave that for about 30 seconds and then change my screen. Okay, I'm going to give you the answers here to choose from. Okay, I'm going to share my answer. I know it's maybe faster, and also the screen that you have now doesn't have the actual answers A, B, C, and D, because the division and everything else, the exponents, just displays in a weird way in that screen. So I just decided to put A, B, C, and D there. So the final answer, the reduced form of this fraction, is B. x minus 1 over x plus 5. So this is a difference of two perfect squares. You're going to factor them and factor the trinomial. Two numbers multiply, it's 5, add it's 6, so it's 5 and 1, and both are positives. And then cancel out the x plus 1 on top and bottom. So you will end up with x minus 1 over x plus 5. Okay, now how can we multiply algebraic fractions? If you remember, with fractions, just regular fractions, if you are multiplying, I'm going to make up this here. So if you are multiplying 2 times here a 4, and that's a 3, and that's a 6, for example, if you are multiplying just regular fractions, what we did already is we cancel out any common factors first and then multiply. So I see 2 and 4. Divide over 2, it's a 1. Divide over 2, it's a 2. And then I have 3 and 6. There is a common factor. Divide over 3, it's a 1. Divide over 3, it's a 2. And then multiply across. 1 times 2 is a 2, and then 1 times 2 is a 2. Will be cancelled out, then it's a 1. So we're going to pretty much follow the same rules. We're going to try to cancel out things just to make it simpler and then multiply across and give the final answer in reduced form. Also, I have the link to our YouTube video on multiplying fractions. This is the same one as dividing fractions as well. So if you want to have a peek into that webinar and see, remind yourself of how we multiplied fractions or divided fractions, you can go to this recorded webinar as well. So we are multiplying this fraction times this fraction. What I'm trying to do here is to make it simpler for me to multiply and reduce. So as for numbers, I'm going to go ahead and reduce the numbers, cancel any common factors between the top and the bottom as possible. So I see a 3 and a 9. Well, over 3, that's a 1, and over 3, that's a 3. And I see 5 and 15. That's over 5. It's a 1 over 5 is 3. Let's rewrite then the question so we are clear on what we have. So we have an r squared t to the 5th c to the 3rd t over 3 c to the 4th times 3r. Now, our job is to multiply the variables on the top, multiply the variables on the bottom, and then cancel out anything that we're able to cancel. So we put our answer in simplest form. So I'm going to go ahead and see what I can multiply on the top. R squared, I don't see any R here, so R squared will stay the same. T to the 5th times T is T to the 6th. Remember, when we multiply same variables, we add the exponents. And then we have c to the 3rd over. We have 3 times 3, it's a 9, c to the 4th r. We're not done yet. We have to look on the top and the bottom and reduce anything with the same variable by subtracting the exponents. So I see r squared and r. 2 minus 1 is 1. So r on the top. So that is gone. We have t to the 6th, but no t's there. So t to the 6th will just stay on the top. C to the 3rd and c to the 4th. Then I have to subtract the exponents. 3 minus 4 is negative 1. So c to the 1st will stay in the denominator. So c's, we're done with the c's, I'm done with the t. Now I have the 9 there. So r t to the 6th over 9c is the reduced form. This is the product of multiplying this fraction times this fraction. Now, what's the illegal values of this? I'm not going to go ahead and find it from the 9c. I'm going to go ahead and evaluate each of the denominators, the original denominators, to 0. So I'm going to have 9c to the 4th equals to 0, and that will give me that C equals to 0, or 15R equals to 0, then in this case, R equals to 0. These are the illegal values. If you go and take your illegal values from the denominator in the reduced form, you are going to be eliminating the R equals to 0, which is going to give you incorrect answers. So these are the illegal values. Question. Any questions on how to multiply fractions with monomials? Okay, let's proceed to the next slide. Okay, now things getting harder. We have two fractions multiplied together. We have binomials, we have monomials, just only binomials, and trinomials. What should we do? Okay, well, with one fraction, if we are dealing with one fraction, we used to factor out and cancel out any common factors, and then that would be our reduced form. For this question, what I'm going to do, I'm going to work in parallel in each fraction. I'm going to factor this fraction, and then try to cancel out anything before I go ahead and multiply. So I'm going to do it like that. I'm going to look at the first one. This is not a usual binomial. This is a difference of two perfect squares. So the way I'm going to factor that is two sets of parentheses, W minus and W plus, once with a 6 and once with a 6. So plus 6 and negative 6. Why 6? The square root of 36 is 6. So I'm done with the first one. Let's do the bottom one. Well, the bottom one is just W minus 6. That's it. I'm not going to be able to factor it any further. Times. I see a trinomial. I'm going to try to factor it like that. So I have a W minus and a W minus. So factors of 6, you multiply them, you have a positive 6, but when you add them, it's a negative 7. So I'm thinking about either 1 and 6, 2 and 3, both has to be negatives because the product is positive, but when you add it, is a negative. That's why both factors are negative. Now let's try. Negative 6 times negative 1 is positive 6. Add negative 6 plus negative 1 is negative 7. So my factors are negative 6 and negative 1. And W plus 6 is just in simplest form. We cannot go further in that. Now let's reduce. Now this is the cancellation method. I'm going to try to make it easier for me to multiply. So I'm going to cancel out things that's similar, that's identical, I should say. So I can go, well, W minus 6 and a W minus 6, or I can cancel this W minus 6 with this W minus 6, as long as you're canceling a factor from the top with a factor from the bottom. Okay, I have another one, W plus 6 and W plus 6. That's gone. That's gone. Okay, so anything else? I don't see anything else. So our reduced form of our product is W minus 6 times W minus 1. No denominator. All the denominators are gone. Illegal values, I'm going to go to the original denominators. So once W minus 6 equals to 0, and then once W plus 6 equals to 0, I'm looking at these denominators. Then in this case, W equals to 6. In that case, W equals to negative 6. These are the illegal values that will make our fractions undefined. Any question? Okay, let's go to a self-check. Multiply 4x squared minus 24x over 3 times x plus 3 times x squared minus 9 over x minus 6. So you have a binomial, you have difference of two squares. What should you do to multiply? Which one is the right product? I'm going to leave that for 30 seconds. And I hope that you try that question. And later on, I'm going to give you the option to input your answers. Okay, I'm going to give you now the option to enter your answers. Is it A, B, C, or D? What is the product in reduced form for multiplying these two fractions that we had them on the screen? Okay, I appreciate your input here. I see that some of you have decided to participate, which is good. Live webinars are meant to have interaction between the instructor and the students instead of just watching a recorded video. So it's good that some of you have decided just to participate and share their answers. So the answer is C. The answer is C. 4x times x minus 3 over 3. Okay, let's move on to the next topic, dividing fractions, dividing algebraic fractions. Now, dividing algebraic fractions has its way from the original dividing fractions, numerical fractions. So if you remember, if we were to divide, I'm gonna just make up any question right now as I'm speaking. So if I'm doing like 3 over 12 divided by, let's say like 4 over 10, for example. So when we divided fractions back then, what we did is keep the first fraction as is, switch division to multiplication, and then flip over the second fraction. So instead of 4 over 10, we're going to have it as 10 over 4. And from there, it's a multiplication problem. We already learned how to do that with algebraic fractions. So let's do that and try to apply the same steps to algebraic fractions. So I have a fraction divided by a fraction. Do not cancel out things before you change your question to multiplication. Remember, cancellation method only applies when you multiply, not when you divide. So keep the first fraction as is. The first fraction, the same exact thing that appears in your question, times, flip over the second fraction, 6xy squared over 10y cubed. The next thing I want to do is to cancel out things from the numbers. I'm not going to touch the variables now. I want to multiply across the variables later and then reduce. But as for numbers, I just prefer to do them now. So remember, we're going to reduce common factors from the top and the bottom. I see 30 and 10. So over 3, it's going to be, sorry, over 10 is going to be 3. And then over 10, it's going to be a 1. And then I have 6 and 5, nothing common, 3 and 5, nothing common, so that's it. So let's rewrite our question. So it is as if we're saying 3x to the 5th y times 6xy squared over, I'm going to combine them in one fraction so I can easily multiply across the variables and the numbers. And I have 5x to the 6th, y to the 4th times y to the 3rd, since that 10 was just a 1 here. Next, let's just multiply across top and bottom, and then cross out anything that's common. So 3 times 6 is 18. X to the 5th times x, remember, add exponents. 5 and 1 is 6, so that's x to the 6th. Y times y to the 2nd, it's y to the 3rd. I'm done with the top. The bottom. 5 times 1 is a 5. X to the 6th times nothing, just x to the 6th. And then y to the 4th times y to the 3rd, add, it's going to be y to the 7th. Okay, well, I have only one variable of each on top and bottom. Now I'm ready to go ahead and reduce the variables. Well, 18 over 5, nothing in common between 18 over 5. It's just going to stay as is. We already reduced the numbers. X to the 6th over itself, just a 1. So this will cancel out. y to the third over y to the seventh. Subtract. 3 minus 7 is negative 4. So the y should appear on the bottom with a fourth exponent or a fourth power. So your answer is 18 over 5y to the fourth. Where do we find the illegal values from? From the original denominators, from the division problem, not the multiplication problem. So you will say, well, 5x to the 6, y to the fourth equals to 0. So that must say that x equals to 0 and y equals to 0 are the illegal values of this fraction. The second fraction, the same thing. Take the denominator, equals that to 0, and see which values would make that denominator 0, so that would make the fraction itself illegal or undefined. So that would be x equals to 0 and y equals to 0. So your two values are x 0 and y 0. So these values will not appear in the graph of this function. If we're going to represent that as a function, then when you graph it, you will find like there is a gap in those values. It's not defined. Questions? Okay, next. What if we have huge fractions like these with binomials, trinomials, numbers? What should we do? The same idea. Keep the fraction, the first fraction, the same. 10x minus 60 over x squared minus 10x plus 24 times. Flip over the second fraction, x squared minus 16 over 15. Next, factor, if possible. So I'm going to take the 10 as a common factor, 10. So it's going to be x minus 6. On the bottom, factor the trinomial. It's going to be x and x. It's going to be a minus and a minus. Factors of 24 multiply gives you 24 and add gives you negative 10. So you will see it is going to be negative 6 and negative 4. Times. This is not just a usual binomial. This is a difference of two squares. So it's going to be two sets of parentheses with x with a minus and x with a plus, and then add the square root of 16, which is 4 and 4. 15 is just a number. You cannot just factor it out more. It's just 15. Now, it's a multiplication problem. Then use the cancellation method. I see x minus 4 and x minus 4. I see x minus 6 and x minus 6. So what is left out for our answer is 10 times x plus 4 divided by 15. And that's your answer. Anything that's not clear in the way we did the division here? Okay. Last self-check, the same topic, divide two algebraic fractions. You have binomial here. You have a difference of two squares. How would you arrive to the simplest form of the quotient of these two fractions? I'm going to leave it for a little while if you want to write down the question and write down the possible answers so you're able to choose when I switch my screen. Okay, I'm going to switch my screen here. I think I give you enough time to write down the problem and the answer. So which one is the right quotient of this problem? A, B, C, and D, or D? Okay, thank you for your input. So the right answer is A. A is the right quotient for this problem. That's it for my math part of the webinar. So we went over how to reduce algebraic fractions. We went over how to multiply and divide algebraic fractions today. If you have just joined on in the middle of the webinar, you will still receive the recording of this webinar in a follow-up email tomorrow. So how would you prepare for the exam? You need to read the study unit. You need to maybe watch again this webinar. You want to maybe watch the available recorded lectures within your lessons or unit. There is practice questions or self-checks, or sometimes they call them discover more questions. You need to practice doing the problems yourself. And I always say in my webinar, it's not enough for students to watch people do the math problems just to, learn them. They have to pick up the pen, write on paper, do mistakes, learn from those mistakes, and this is how you learn how to work out the math that we go over here in this course and any other subject, really. Even in English, if you just listen to people who speak, it does not mean that you're able to write your own essay. Also use the answer key for those questions. The practice exercises or discover more questions have the answer keys available to you. So if we're closed and you're working on your practice questions, you don't have to wait for us to reopen next day. You can just look up your answers and see if you get most of the answers correct, it means that you are ready for the exam. If you get them mostly incorrect, it means that you should not proceed to the exam. An outside resource that I like to provide my students with is khanacademy.org. It's not mandatory for you to go and have a look at them, but some students have asked me in the past for extra resources. So this is one of them. If you go to that site and go to the top left corner, you see subjects. You're going to click on subjects. You're going to choose Algebra 1, if I'm not mistaken. If you don't find these in Algebra 1, maybe click on Algebra 2. And then go to rational expressions. This is the name of the lesson. And the sub-lessons under that corresponds to this webinar is simplifying rational expressions and multiplying and dividing rational expressions. So rational expressions are the algebraic fraction, just another name to them. And also, if you need help in your lessons, you can email your instructor. You can text a message. You can also call during the day. You can schedule an appointment. So you have multiple ways to reach out to your instructor. Thank you so much for attending the webinar. Thanks for your interaction and thanks for your time. And thank you for whoever also registered for this webinar. If you have questions for me before I end the webinar, I'd like to answer them. You can type them in the questions box. Well, thank you everyone then for your time here today. There is a small survey that I added to this webinar. So at the conclusion of this webinar, you will see 3 short questions. If you would like to give me your feedback on this session, I'll be glad to read your answers. Also, students who registered but did not attend will have a chance to take the survey and just let me know how I did during this webinar and what they'd like to see in future webinars. Thank you for everyone and good luck in your exam.